x, length x plus 8, height 3x minus 1, volume 2100. What are we trying to find? We're trying to find x, which will give us the length and then give us the height. So we want to find what's the number that's going to represent x. These are length times width times height because it's a rectangular box. I have the volume, so I'm going to put it on the left-hand side. I have the length, so I'm going to put that on the right-hand side. I have the height, and I have the width. What your brain is going to want to do is start to multiply this out. Don't. You can if you want to, but if you make a mistake, you won't get the right answer and you're doing work you don't need to. But your brain is going to want to start to multiply this because that's what we've told you to do. This is a calculator question. They would never ask you to try to solve this by hand. So because it's a calculator question, the calculator doesn't care if you type it in like this or you FOIL it out and you type in the terms. It's irrelevant to the calculator. What you need to decide is which method do you want to use on the calculator. What was method 1 called? Left-hand side, right-hand side, intersect. Method 2 is? Everything to one side, and we find the intercepts. What is the work you need to show me for a graphing calculator question where you're solving an equation? And the points, and people are still blowing those marks on tests because they're just writing down the answer. So make yourself a note. Do not FOIL or do not multiply whatever's going to make sense to you because it's what your brain is going to want to do. It's irrelevant to the calculator. Do not multiply, do not FOIL, do not, no touchy, whatever, no touchy. Would you like to do method 1 or method 2? I knew you were going to pick one. So 2100 for y1. And this we're going to type exactly what we see. Calculator doesn't care if it's simplified or not. Go into Zoom. Now we usually pick Zoom standard. The problem is the Zoom standard goes from -10 to 10. Can a volume be negative? No. Can a height be negative? No. So we don't need the negative part. Do you think with a volume of 2100 that the dimensions are all going to be less than 10? Probably not. So what you can do is Zoom standard, then change your axes. What I go down to is what's called Zoom fit, which you probably haven't used before. And Zoom fit is saying to the calculator, you pick. It's kind of a crapshoot. Sometimes calculator does a really good job, sometimes calculator does not. So it's like, hey, calculator, show me what you got. So hit Zoom fit. And all I care about is, can I see where those two graphs cross? That's all I care about in this. Yes, they're showing us some negatives, but we don't care. I just need to know, can I see it where they cross? I'm going to zoom standard and show you what happened when we zoom standard. And then you're going to come up and tell me your calculator is broken because you can't see anything. So zoom fit is a good one for these questions because we don't really know what the number is. And zoom fit is saying to the calculator, well, you kind of figure out. Sometimes the calculator doesn't pick good numbers and you still won't be able to see where they cross. That's when you have to go in the window and start playing around. So make yourself a note, zoom fit first and see what the calculator gave you. You just need to be able to see where these cross. So the work is just a sketch of the graph. I just sketch what you see. In essence, I could just do the first quadrant, but just do what you see. It's just telling me I looked at my calculator, this is what was there. We need to mark that point. How do we get the calculator to give us that point? Second, calc, intersect. Make yourself a note. We've talked about this every time we've done calc questions. The y value is irrelevant. The y value is irrelevant. It doesn't matter. We're trying to solve for x, not for y. And in fact, in this case, what the y is that volume. And we already know that. It's irrelevant. It's not what the question has asked us. Are we done? Have we answered this question? No, it wants the 3 dimensions. All we have found is the width, because the width is 7, x is 7. How do we find the length? 7 plus 8, which is? What about the height? And then we just need to find what kind of units are in the question. Is this meters, centimeters, units, inches, millimeters? It's just units. So it's 7 units by 15 units by 20 units. There's problem solving with a polynomial. What step do you think is going to be the hardest? What step do you think is going to be the hardest? Interpreting the question and getting this equation. That's the hardest part. Once you have this set up, the calculator does all the work. It's getting what this equation is. Step 1. What did we do first? It's a little general. Ooh, set up equation. I'm going to make the note that it's usually going to be a bunch of binomials multiplied by each other. Why do I say that's usually going to be the type for these questions? Because it's polynomials. So it's usually going to include the multiplication of binomials. Usually going to include the multiplication of binomials. Toss into calculator. Okay, calculator, here you go. Oh, it didn't work so well. Make a note here about the zoom. Zoom fit, which is 0. Again, it'll work 95% of the time. Sometimes calculator's a little bit off. Calculator's pretty smart that it usually knows we want to see either the intersects or the intercepts. So it's pretty good at putting them in the window. Okay, child graph, I like that. Mark points. Well, this depends on the method that you use, so I'm not sure how we want to word it. Ooh, intersect / intercepts, will that make sense to you? And the last one, I just want to make a note that's going to say answer the question. And what I mean by that is you're going to want to stop when you get this x equal to 7, because that's what we usually do. We get a graph, we mark the points, we get an answer, we're done. But is that necessarily the full answer to the question? So answer question completely. number 2, read to read. Don't overthink. Just read it like it's a sentence in a book. What's it about? A box. What do I need to highlight? What's the most important pieces? Yeah, cubic centimeters. What's the difference between example 1 and example 2? We don't have the volume for this one. Okay, so let's see how that's going to differ. Does it matter which dimension is which? No, to a mathematician, we don't really care what the length, the width, the height is. They just all have to be the 3. So I'm going to call that one x. Why not? Which makes this 9 minus x and 11 minus x. Volume, don't know. Okay, so volume still length times width times height. I realize I put them in a different order, but it doesn't matter, as long as I have the 3 dimensions. But what do? I don't have the volume. Yeah, it doesn't matter for this one. They're not asking you to solve it. What are they asking you to find? The maximum value. How did we find max and mins of a parabola? So back from last year, how did you do these questions when they were just max-min problems? Yeah, so when we go into second function calc, what do you see in there? Maximum. So I just want to go back to step 4. It could be max slash min, just depending on what the question is asking. So it could be intersect, could be intercepts, could be max or min, and it will just all come from what the question is asking. So in terms of using our calc, what it means is we're not going to have a y1 and a y2. We're just going to have y1. So we're just going to put in the right-hand side as we see it. So x, 9 minus x, and 11 minus x. Zoom fit, see what the calculator wants to do. Oh, which by the way, when you go into Zoom, get out of here. If you go Zoom, if you go 1 up instead of going all the way down, it wraps around to Zoom fit. You can click the 0 as well, yes, either one. Okay, so you don't have to go all the way down to 0, you can just go 1 up and it wraps around. Yep, pretty much. What are we looking for? So we're not looking for where the lines cross. We're looking for a max. How did the calc do? Not so good. It's showing us kind of here, but we need to know what's going on here. So what axes do I need to change? What do I need to see more of, and what do I need to see less of? More of positive y or y max, and less of y min and x min. Okay, so go into window. Well, I can put the mins at 0 because I know I can't have negative volume, negative length. What did we think of 10 as the x max? I heard 20, 30, 100. Okay, let's put 50 and see how it goes. We can always go back and change it. I'm going to put 0 for the min because, again, we don't need the negative. What do you think for the max? Okay, let's try it and see what it looks like. How do you get the graph now? What do you tell the calc? Just graph, and it will give you those axes. Oh, cute. Well, can we see the maximum point? Can we see the maximum point? Sure, because we know this goes up to infinity because it's a cubic. How do we know it's a cubic? X times x times x. So we actually showed a little bit too much x, but that's okay. As long as we can see the max, we're happy. Boop.
So everyone's answer for this graph is different.
No, everyone's graph may look different. Their final answer should be the same. Yes, the graph will look different depending on what you pick. Bless you. Now how do we get the calc to tell us what that max is? It's the second calc. Now what? So I need to go to the left, so I got to go backwards for where mine ended up. Oh, here he comes. Okay, so somewhere on the left of the max, somewhere on the right of the max. Okay, so exactly what you do with quadratics, this just happens to be a cubic. Is that good for our rounding? We'd like it if these were whole numbers, but they're not always going to be. That's not the way the real world is, so don't freak at this point if you get a decimal. Have we answered the question? No, all we have right now is the width. What were the units?
Centimeters.
How do I get the length?
No.
How do I get the height? I heard 7.7 and I heard 8.7.
Yeah, 7.7.
And then because I'm left-brained, I always just write them together as the last step. You don't have to. It's just the way my head works. No, it's what are the new dimensions, and we tend to give them all as a string like that, just like I did up here. Oh, it wants the max volume. Sorry, I wasn't reading the question. I need to go back to the calculator. That's the x that gives us the max volume, but what's the max volume? It's the y value. For maximum, it does. That'll always be the max volume. Sorry, my fault, didn't read the question. I really should have highlighted the key stuff so that they really stuck out for me. Yeah, you could, absolutely. It's just why do the work when the calculator's doing it for you, right? So you might want to make a note with maximum, it's the y value. As a left brain, I want to totally recopy this whole sheet. Lefties understand. I know. If I had a erasable pen. Are we okay after the screw up there? Dimensions, they're always the long ones. Read to read. Probably partway through you start to think, who cares? Well, somebody has to care. Just think about it. Every product on the shelf, so picture your local supermarket. Every product on the shelf, somebody determined those dimensions. Do you think they just willy-nilly? Yes. Absolutely not. How do companies determine their packaging?
By careful calculation.
Because what are they trying to conserve? It's money. They're trying to conserve the amount of materials, which brings down the money. They don't care how much space it takes on the shelf. That's a grocery store's problem. But all packaging is designed for a certain reason. So you might not care, but the engineers who work for this company, they care because that's their job. Okay, what's important? Do we care it's sugar? No. We care about the original dimensions. And we know we want to increase each one by the same amount, because we want the capacity to increase by 350. New dimensions. What's the math word for capacity? It's volume. So we want the volume to increase, and we want to increase each one in the same proportion. Again, I'm left brain, so I'm going to show you the left brain way that I do it first. grabbing my ruler because I can't help it. I compare old with new. And I want to compare the 3 dimensions and the volume. If this little chart does not work for you, you do not have to use it. This is just the way my brain processes the information. I know the old length was 13 and the height was 13 and the width was 25. How did I know which is which? It doesn't matter. I could have put it 25, 13, 13. I could have put 13, 25, 13. To a mathematician, it doesn't matter. Those are just the 3 dimensions. Because I want to increase them by the same amount, what I want to do is add the same amount to each one of those 3 dimensions. How much? We don't know. What do we put in math when we don't know something? So I'm going to make this one 13 plus whatever x happens to be, because I want to add to it. I'm going to make this one 13 plus the exact same amount, so x. And the width I'm going to make 25 plus x. And the only reason that they're all x is because the question has specified by the same amount. What I want to have happen is I want to increase the volume by 350. What do I need? The old volume. Well, how do you calculate volume of anything? Length times width times height. So calculate the old volume. So it would be 13 times 25. 4225, I heard? And so I'm just going to make a note so when you look back, this just came from multiplying length times width times height. And so that means I want the new volume to be 4225 plus my 350. Can someone just confirm the new volume should be 4575? And I'm going to highlight this column because it's the one that really matters. We're now at the exact same question as we were for question 1. It's identical. Here are the 3 dimensions. Here's our volume. Let's figure out the dimensions. So what did we do in question 1? What are we going to put on the left? What is our new length going to be? What is my width going to be?
25 plus.
I actually meant my height because that was next, whatever. Well, we would never write the binomial out twice. What would we do? We would square it. Seriously, you were like 2 seconds ahead of me there. If you happen to write it out twice, who cares? The calculator knows the difference. Just as a mathematician, I can't do it. It bothers me. Okay, you walk me through the calc. You tell me what to put in.
So you 4575. Go down to y2. Square bracket. 13 plus x. Close that bracket. Put a square. Another bracket. 25 plus x. Go to 0.
Just want to make sure everybody's at the same step. What are we missing? Yeah, the line isn't there, so what do I need to see more of? Okay. I did. Grr. Did everyone else get it, or anybody like me that it didn't show? What? Just me? Are you kidding me? Okay, so I'm going to go to Y max, and maybe you guys can tell us what your Y max is so we can just steal it.
Mine was 18,515.
But that's lower.
It's 1,655.
It's, yeah, the min.
It's a min. What should we put our min at?
35.
I just have to 0. I just have to because it's a Y min. And sorry, this was 18,000? There's our line. Oh, we still can't really see where it crosses. What was your X values?
But once you calculate for that,
-10 and 30. 10 and 10.
Sorry? Oh, that's, yeah, the calculator figured it out. I just want to see where it is. Do you have to draw the graph?
Yes.
Do you have to mark the point?
Yes.
Well, only if you want full marks, and some of you still don't. Second function, calc, intersect, 0, maximum. What are we doing here? Rounding instructions? There isn't. What's the default? I've mentioned this before if there's no rounding instructions. 3 decimal places if there's no rounding instructions. Are we done the question? No. What do we need to find? Okay, so the new length. The new height. And the new, what have I not done? Width.
Does it really matter what you choose?
Not at all. Oops, centimeters. Was it centimeters?
Yes.
Centimeters. Why is the number so teeny tiny?
Because it's just.
Yeah, well, look how much we're adding to the volume. Right, if our volume's at 4,200 roughly and we're adding 350, that's such a tiny little amount. So it's not going to change our packaging very much. How are we feeling so far? Meh. I'll take meh at this point.
Good. Great.
Age. These are like the stupidest questions ever. When are you ever going to do this? Never.
I hate you. I'm 3 times older.
Seriously? Even I don't sit around at parties and do this kind of stuff. And I'm a pretty big math nerd. The government says we will do them, so we will do them. What it's about, nerdy Leo? What do we need to know? So what's key here?
Sandra, no, she's 3 years. Is graded in the same.
S is equal to 3 hours.
Oh, you're already starting to think. Let's just get the keywords first.
Sarah knows she is 3 years younger. She could actually know how real it is.
Hunter.
What's up with this? Yeah. What's up with this? Yeah, actually,
1 year older or 1 year old? Because those are very different.
1 year old.
Yeah, he can't even talk yet. Come on, Leo. That's it? That's all we need? Oh. Product of their ages.
Math nerd.
AKA loser. Anyway, that deserves its own color.
Sandra knows she's 3 years younger.
You'd think she'd know his age, wouldn't she? Yeah. But to be fair, I'm 3 years younger than my brother, and I always have to take my age and add to figure out how old he is. I don't just know it. Like, I'm 40, so he's 43. Like, but I know I'm 3 years younger. But you think of it. Maybe she's doing it to make Leo happy. You know, like maybe, you know, she just wants to humor Leo. Do we know Leo's age? No. So what do we write down in math when we don't know someone's age? What do we know about Sandra's age in terms of Leo's age?
S plus 3 equal to S I said
I don't want to introduce a new variable, so I'm just going to call her Sandra. Vince?
no, I said S as in S.
Oh, is it minus? Sorry, she's younger. Minus.
Come on, Chad. Man.
Because she's younger, so we have to take it away. Vince? Okay, so the key there is he's not 1 year older, so you have to read the question a little bit carefully. Okay, we got this big number. So the product of their ages is that number greater than the sum. So we're going to need the product and we're going to need the sum. How do we find the product of stuff?
Multiply.
So that would be x times x minus 3 times x plus 4 times 1. Do we need the 1? No. We're going to need the sum as well, so how do we find the sum of numbers? So x plus x minus 3 plus x plus 4 plus 1. Do we need the 1 there? Yes, it's important in the sum. It's irrelevant in the product, but I like to put it anyway. Let's just simplify up the sum because it's easy to do and there's a whole bunch of terms hanging around. That sounds confirmed at the same time. Okay, how can I use this 54,600 whatever? Okay, so the product is 54,658 greater than, what does that mean? It means add to the sum. So I just translated that sentence. The product is 54,658 greater than the sum. Do I have the product? Well, I have an expression, so I can put that on the left. Again, I could FOIL this out. It's just not irrelevant. Just like I didn't have to simplify here, but it was easy, so I did. And this is going to be 54,658 plus 3x plus 2. Could I simplify this? Sure. But the calculator will get it. Yeah, stupid Leo. Questions on where this has come from. This is the hardest part, is getting this equation. Age ones will always work like this.
I don't know who was super in this equation. Leo for saying this big equation.
Yeah.
French could just add up.
I think we can leave Hunter out. I don't think it's his fault. I think Hunter's okay. But what if he's the son of Leo and he's going to inherit this? What if he's the son of Sandra and Leo? It could be terrible. What am I going to put into y1? What am I going to put into y1? Yes. Do you want me to type the word stuff? I could. I can't find the S. Where's the S? Where's the S? S. T. U. Where's the F? F. There we go. Stuff. It depends. It depends how you've stored them in your calculator. Now, what would you really like me to put into y1? No. Like, really, do you think I would make this up? Like, you really think I would make this up? I enjoy the dimensions one because in engineering there's a purpose, but the government said you must be able to solve dimension and age problems. I put in that he's a huge math nerd. That might have been my little contribution. But. Y2, what should I put? And if you wanted to combine these and put them together, that'd be fine. Now I'm kind of nervous. Mine's not going to work as well.
Pretty sure it was 5, 4, 6, 5, 8.
Oh, oh.
Not 8, 5.
5, 8. Shame. That's probably not going to still work for our graph. Okay, I got to fix it.
Make it 40.
Okay, I can zoom standard it. Well, that worked for the cubic, but I know I got to be at least 55,000 here.
Has to be 54,000.
So I can change the Y max.
Make it 55,000.
Probably want to see higher. Can we do 60?
Sure.
See what that looks like?
X max should be 40.
Okay.
What?
Yeah, and then my cubic's way down here now, so I need to change my X max. 50, 100.
75.
No one to be like 100 years old for this, or they're really in trouble.
Oh, that's pretty.
What were those coordinates then?
Oops, sorry. I really want to put the zeros for the min. I just have to because we can't have negative ages.
Are we just going to 2 0 decimal places to turn into age?
I want to know his age right now.
Mine is so close, but off by 0.002.
What's the default when there's no rounding instructions? The exceptions. Things like people, objects, animals, ages, unless you're under 5 and you start counting, I'm 4.5, right? That stops when you're 5. Money would never be to 3 decimal places. What would money be? So use your logic skills. Obviously, no one says I'm 37.751. What is his age going to be? 37. Yeah, when you're old, you don't round up anything when it comes to age at all, ever.
7-year-old hanging out with a 1-year-old.
Maybe that's his son.
Well, it doesn't specify he's his son. Hunter's just some random kid. 37-year-old.
Are we done? Answer the question completely. Are we done? Not that. What is the question? Ask for everybody.
I don't know how old I don't know what Hunter is doing over there.
He's their child. Or they're in a van and he kidnapped them. But let's not talk about that.
41.
He kidnapped the mother and the son.
Friends, infants.
Just hangs around daycares.
Hunter was given, so it's assumed.
2